Hello, my name is Miwa, and today I'll be talking about the mucus layer of the small and large intestines. Before actually getting into the topic, let me explain how the highlights in my slides work. Red highlights are for terminologies that you must know for the exam. Orange is for terms recommended to know for ACE in the exam, though not essential. And green is for terms that you do not need to memorize, but just good to keep in mind. Now let's start with the basics. What is a mucus layer? It's another name for the mucosa. The mucosa consists of the epithelium and the lamina propria, which is loose connective tissue. In the GIT, the muscularis mucosae, a thin layer of smooth muscle usually joins the mucosa. Below the mucosa is the submucosa, followed by the muscular layer with inner circular and outer longitudinal layers, and finally the serosa in peritoneal organs or adventitia in non-peritoneal organs. Now, let's look at the common structure in different parts of the small intestine. The epithelium is simple columnar and includes goblet cells, which secrete mucin, enterocytes, which absorb nutrients, and Panel cells, which are involved in innate immunity. This epithelium forms intestinal glands or crypts of Lieberkühn. Below the epithelium is the lamina propria, which may contain lymph nodules, commonly seen throughout GIT. Plasma cells in these lymph nodules secrete IgA. The lamina propria is followed by the submucosa. The submucosa forms circular folds, or pulice, and the mucosa forms villi. Beneath that is muscularis with its inner circular and outer longitudinal layers. And finally, the serosa. Because the small intestine is a peritoneal organ, it doesn't have adventitia. The intestinal wall also contains the enteric nervous system, including the Meissner plexus in the submucosa and the Auerbach plexus between the circular and longitudinal muscle layers. These images show more details of the villi and the crypts of Lieberkühn. Inside the villi, you'll find the capillaries, lymphatic capillaries called lacteals, and sparse smooth muscle cells. The upper part of the crypts of Lieberkühn contains enterocytes and goblet cells, while the lower part contains Panel cells. There are also enteroendocrine cells that secrete various hormones depending on the cell type. Examples include I cells, EC cells, K cells, L cells, MO cells, N cells, and S cells. Now, let's focus on some important cells in the epithelium of the small intestine. Goblet cells secrete mucin, a glycoprotein. They appear pale with regular staining like hematoxylin alsin due to their abundant lipid content, but they stain bright pink with PAS staining and blue with Alcium blue. Enterocytes are columnar cells with an oval nucleus. They form the absorptive epithelium with densely packed microvilli on their apical surface along with glycocalyx. Enterocytes exhibit alkaline phosphatase activity, which is why they are stained by azo coupling. Their functions include absorbing sugars, amino acids, lipids, water, electrolytes, vitamins, and bile salts. Panel cells have microvilli and eosinophilic granules in their apex, giving them a red appearance under the microscope. They are located at the bottom of the crypts of Lieberkühn and contribute to innate immunity by secreting lysozyme, phospholipase A, defensins, and also other substances. The small intestine is divided into three parts: duodenum, jejunum, and ileum. I will go into different structures in the different parts of the small intestine. First, duodenum. The duodenum has relatively shallow crypts of Lieberkühn and contains Brunner's glands, which are mucus secreting and found in the submucosa. Do you recall another place in GIT which has glands in their submucosal layer? Yes, it's esophagus. The villi in the duodenum are said to be leaf-like, but not always clearly visible under the microscope. The jejunum features the common structures we discussed earlier. Its crypts of Lieberkühn are deeper compared to those in the duodenum, and the villi in the jejunum are described as finger-like. The ileum has shorter villi and contains Peyer patches, which are part of the mucosa-associated lymphoid tissue or mold. A notable cell here is M cell, which has a conspicuous dome-like shape with a hollow interior, without brush border or glycocalyx, and with sheave-like basal lamina. M cells help nearby plasma cells produce IgA. Let's move on to the large intestine. The epithelium here is also simple columnar and includes goblet cells and colonocytes, but lacks Paneth cells. There are no villi or circular folds in the large intestine, unlike the small intestine. The epithelium is followed by lamina propria, muscularis mucosae, and submucosa. The muscularis has a circular layer, and the longitudinal layer is present only as teniae, strip of smooth muscle that include the free tenia, omental tenia, and mesocolic tenia. You might wonder why we are skipping the appendix. Don't worry, it'll be covered in the immune system lesson. Now, let's take a closer look at the colonocytes. Their function is to absorb water. Colonocytes have microvilli on their apical surface as well as in the intercellular space. The microvilli in the intercellular space are often interdigitating, which helps with water absorption. The dilation of the intercellular space is an indicator that water absorption is occurring. Finally, how can we distinguish between slides of the duodenum, jejunum, and large intestine? For the duodenum, always look for simple columnar epithelium with mucus-secreting Brunner glands in the submucosa. For the jejunum, look for red Paneth cells at the bottom of the crypts of Lieberkühn. In the large intestine, the crypts of Lieberkühn look straight because there are no pulicae or villi, and the sections are typically uniform rather than some appearing chopped while others look straight. And that wraps up the key points about the mucus layer of the small and large intestine. I hope you found this interesting.